Okay, and we're back. Yeah, they probably won't listen. These are for you, Matt and Ashley. Here we are, 8-4, last day, our last day of hypothesis testing. We are hypothesis testing the difference in population proportions. And if you remember, I used capital P here, even though it's a lowercase p, just to distinguish the population proportion from the p-value from our programs. So it's P1 minus P2 that we're testing. So with proportions, the samples must be independent. So no overlap again. The samples must be large enough to be normal. And for the proportions, it's not the magic number 30. It's sample size times the proportion of the first sample has to be greater than or equal to 5. Sample size, times the failure percentage has to be greater than or equal to 5. And then the same thing with the second sample. Sample size times the probability of success greater than or equal to 5. And sample size times probability of failure greater than or equal to 5. So now you got 4 checks to do. Okay. P bar is it's going to be used in the formula. To get P bar, it's the number of successes from the first sample added to the number of successes from the second sample divided by the 2 sample sizes added together. And then our sample difference in proportions is going to be P hat 1 minus P hat 2. And to turn that difference into a z-score, I forgot to tell you these were z-scores. The z-score for P hat 1 minus P hat 2. The numerator's been the same all the way through. P hat 1 minus P hat 2 minus the difference in proportions from the whole.
Okay, with that, is that only a real number if they're like, we're 9 more?
Right. Otherwise it's going to be 0.
Okay.
Yep. And then the denominator is where we're slightly different than before. Square root. You need P bar, which I gave you in step 3, times Q bar, times 1 over N1 plus 1 over N2. So we'll go through one by hand using our formulas, one with a program and a confidence interval. All right, so it says, consider the results of the Journal of American Medical Association study discussed in the chapter opener. We didn't discuss that. At alpha equals 5%, can you conclude, so there's the claim being made, that the proportion of Vietnam Army vets who suffer from alcohol abuse or dependence is greater than the proportion of non-Vietnam vets? All right. So the proportion of Vietnam vets suffering from alcohol abuse is greater than the proportion of non-Vietnam vets. We're going to test this at 5%. And then the data that they came up with so we've got Vietnam, non-Vietnam, got to go back and see. Let's see. Oh, they had a survey of 7,924. That's a pretty large sample. Alcohol abuse is X. That's 1,008. Oh, let's see, 1,085. And the non-Vietnams, they had a total of 7,364, with 678 suffering the alcohol abuse. Because it's a number of successes. So we're going to make a proportion out of it. All right, so same thing as before, we start rewriting the claim. And the claim is talking about proportions and not means. That's why there's no bars here. So the claim is that the proportion of Vietnam, I'll use V for Vietnam, and we're comparing to the proportion of non-Vietnam. And what are they saying about those two proportions? Vietnam is bigger. And now we want to compare the difference, so we'll do the subtracting. There's your ha. Oops. There's your ho. Okay. We should be checking the sample size to make sure it's big enough, but I'm pretty sure that 7,000 is going to get us over 5 successes. We already know how many successes we had. It's into the thousands. So the check for normal is good. And how about I just promise to not give you one that doesn't work so you don't even have to do the check? How's that? Okay, so we won't worry about the check. So what tail test are we going to do? Right tail. This was 5%. Makes this 95%. And because our sample size was big enough, we are back to z-scores. I haven't had a z-score in a long time. How do we get that critical z-score? Inv norm of the 9.5. What's behind you? So it should come up positive. 6.4. Okay. All right. Now, so we need to know p hat 1, p hat 2, p bar, and q bar so that we can plug into this formula. So I think I'm going to take the time to just find these off to the side. So p hat 1 What am I talking about when I say p hat?
Sample difference and
It's the proportion from sample 1 that were successes. In other words, they were suffering from alcohol abuse. So how do I get that proportion?
over
X over n. So it's 1,085 over 7,924. So then p hat 2 is 678 over 7,364. I also need p bar. And p bar is add your successes together, divide that by the 2 sample sizes added together. So we got 1085 plus 678 over 7,924 plus 7,364. So what are we going to come up with? I'll do the bottom, you do the top. The p bar. We'll just leave them as fractions. 15,288 I got for the denominator. What's the numerator? 63. Okay. How do I get q bar? Because I need q bar too.
you take the 763
Subtracted from the total. So it's the number of failures. So 15,288 minus 1763. 13,525 over 15,288. Okay, ugly fractions, but now it's just plug and chug. So the z-score for my p hat 1 minus p hat 2. So I start with p hat 1, 1085 over 7,924 minus 678 over 7,364. The whole has a 0 in it. Denominator, p bar times q bar. And then 1 over each sample size. Okay. Calculator challenge. I don't know if I can do this all in one line. I'm going to go for it.
You have to have a parentheses before you put the square root down.
Nope, because there's only one square root down there. Oh, it's not bad. You don't need too many extra parentheses. Let's see if I type that in right. What'd you get? Up on top.
8.87.
Did you? Oh. 1085 divided by 7924. 678 divided by 7364. That's in parentheses. 1763 times oh, I got a 7 in there. Right at the very end, I want a 1. Is that what you guys got? Oh. Oh, why is it not? Oh, it's not using the ones connected. That's why. 8.68?
Yeah.
Oh. That explains why you can't see it. All right, I had a mistake. A 7. I don't even know where I pulled the 7 from. Okay, so where does that put us? In the shaded. Well into the shaded. So we'll reject the hoe, making that claim true. Vietnam was bad on those vets. Almost there. Yep, they're both programs. So the program for this section, impress me now, what's the name going to be? You're close. It's going to be a prop test. How many samples do we have? 2. Samp. 2 samp. Prop test, is that what they call that? I think so. 2 prop z-test. Oh.
Do you not know?
I'm not looking. I was trying to get it myself. It's 2 prop z-test because we're hypothesis testing. The next example, we're going to do an interval.
Okay.
So make sure when you do the testing, you end in test. 2 prop z-test. I thought it was 2 samp. I better check before I go with it.
There is a 2 samp. 2 prop z test and then there's a 2 prop z int.
Yeah, we want 2 prop z test, and then we're going to use 2 prop z int after on example 3. Okay.
Wait,
Nope, it's prop for proportions. So the 2 samp z is when we do means. Okay, well now we did the grader. Okay, let's go with the new claim that the proportion of Vietnam vets who suffer from anxiety is different than the proportion of non-Vietnam vets. We're going with 5%, and we're going with a program. So we'll restate that claim, and then run the program. Oh, after I give you the data. Okay, so we've got proportion, so we need a P. Vietnam, and comparing to the proportion of non-Vietnam. What are they saying about the 2 proportions? Not equal. So as a subtraction, there's your ha. Your ho is going to equal 0. Okay, and then I'll show you the table. Or I'll look at the table. So we still have the Vietnam, that same sample size, 7,294, and now the anxiety, 388. Sample size 7,364. And anxiety here, 236. All right, let's see what's going in this program now. 2 prop. Okay, so we got x1. X is the number of successes, so if they gave you a percentage here, you'd have to multiply to get that whole number back. So x is always, I suppose I should choose the right one so you can see it. So, 2 prop z6. All right, so number of successes from the first sample, 388. 7294. 236. 7364. We are not equal. Lots of p's there. Which p do we want? Just the p. Oh, I see a 2.30. That tells me look at the end of the line because it is in scientific notation. It's times 10 to the negative 10th, which is essentially 0. So what are we doing to the hoe? Rejecting. P is smaller than alpha. Not likely to happen. We reject the hoe. Making the claim true. Okay. Oh, still have our confidence interval. Do the same data. The confidence interval is 2 prop z int. And let's go with 95% confidence level. Everything's still there. Nice. So we'd expect the difference in the proportions to be between, very close, 0, 1, 5 and 0 to 7. So between 1.5 and less than 3%. Okay. What do I have for your last, well, maybe not last homework. White book, here you are. Stats. Page 404. Even, let's see here. Let's review. Testing the difference. Let's go, how many are there? 1, 2, 3, 4, 5, 6. So the first 3 will be by hand. 8, 10, and 12 will be by hand. And then the last 3 by program.